Hi, this is the next video for Year 13 Further Maths, working towards exercise 7D. It's finding those arbitrary constants using boundary conditions. So now we're finding A and B, and this is the final piece of the puzzle really. This is how we get the full solution to the particular solution to these equations. We've been looking at general solutions up until now. Now we're going to be equipped to find A and B. So example 15 then, I'm given my differential equation, but I'm also given three extra pieces of information, and I'm going to use these to find my A and B. So I'll go through the same process. I find the general solution, then I sub in, and then I find A and B. So my auxiliary equation, m squared minus 1 equals 0. So m squared equals 1, m equals plus or minus 1. So my conditional function then, y equals a e to the x plus b e to the minus x. My particular integral, I'm going to try, well, I can't do alpha e to the x because I've already got an e to the x term. So I'm going to use alpha x e to the x, differentiate using the product rule. V is e to the x, so v dash is e to the x. So the product rule, remember, u dash v alpha e to the x plus u v dash alpha x equal to the alpha x e to the x. Differentiate again, alpha e to the x. Now I've just differentiated alpha x e to the x, and it's alpha e to the x plus alpha x equals alpha x e to the x. So I don't need to go through that whole rigmarole again. Tidy that up. Okay, and sub in to my original equation, 2 alpha e to the x plus alpha x e to the x minus y minus alpha x e to the x, and that equals 2e to the x. So alpha x e to the x minus alpha x e to the x goes, so 2 alpha equals 2, alpha equals 1. So my particular integral then is x e to the x, and my general solution is my conditional function plus my particular integral. Okay, none of that's new. Now this is the new bit. I've got these three pieces of information, and so I can generate two equations, one of which I can just sub in x and y, x equals 0, y equals 0. The other of which I'm going to differentiate and then set dy dx equal to 0 and x equal to 0. So y equals 0, x equals 0 gives me 0 equals a, e to the 0 is 1, e to the 0 is 1, and 0 times e to the 0 is 0. So there's my first equation. Differentiate my general solution gives me a to the x minus b to the x. Now x e to the x, let's do a quick product rule here. V equals e to the x, v dash equals e to the x. So u dash v plus u v dash. And I'm going to sub in dy dx is 0, just squeeze this in on the bottom. X is 0, so a minus b, e to the 0 is 1, and my last time goes to 0. So there's my second equation. So my two equations, if I solve simultaneously, well, I can see straight away if I add these two, 2a plus a is 2a, b minus b cancels out. So I get 0 equals 2a plus 1. To show you the equations again, add them together, 0 equals 2a, b minus b, and 0 plus 1. So a is minus a half, which means because a plus b is 0, b must be a half. That means my general solution, my particular solution, I'm sorry, is minus a half e to the x plus a half e to the minus x plus x e to the x. So up to this point, general solution, that's what we got before. Not a lot extra really to do here. Given those pieces of information, generate my two simultaneous equations and then solve and rewrite my general solution as my particular solution. Of course, now it's particular because for these values, I've got my values of a and b. So that's the final step. And as I say, it's not a massive step. It's not the hardest thing in the world. It's just remembering how to generate those two equations. In fact, I'd say probably the actual differentiation is the hardest part, but it's still not the hardest thing in the world. Okay, example 16. Now this is interesting because they do this in exams sometimes. They've told me the form of the particular integral. So they've told me when I get to find my particular integral to use that form. Now looking at it, that's probably the form I'd use anyway, but okay. And you know, I'll keep on doing this. For this question, it's x, not y. So I've got dx dt and x. Well, that's not a massive problem. It's just x and t instead of y and x. I'm also told that x is 0, dx dt is 1 when t is 0. So, same process again, find the general solution, sub in my values, find the particular solution. So my auxiliary equation, m squared plus 1 equals 0. So of course this has complex roots now. And remember, for complex roots, it's e, I've done it here again, it would be e to the alpha t plus times a cos b to t plus b sine b to t, but there's no real part here, so my alpha would be 0, so my conditional function is just a cos t plus b sine t. Now here's a good reason, here's a reason that watching videos is good. Pause it, get your head round this step, understand how I've got from there to there. So that's my conditional function. Like I say, if you need to pause, do. My particular integral, I'm told, my particular integral, remember they said, is lambda sine 2t. Well, I'd have used that form anyway, but okay. So dx dt is 2 lambda cos 2t, and d squared x dt squared is minus 4 lambda sine 2t. Sub into the original equation, minus 4 lambda sine 2t plus lambda sine 2t is equal to minus 3 lambda sine 2t, and of course that's equal to 3 sine 2t, which means lambda is minus 1. So my particular integral is minus sine 2t. And my general solution is conditional function plus particular integral. Nothing new so far. Here's the new bit. Let's sub in these values. I'll do x and t to generate one equation. So 0 equals, well, cos of 0 is 1, sine of 0 is 0, sine of 0 is 0. That was nice. So a is 0. Now I'm going to use the fact a is 0 to write out my general solution again, then differentiate, Makes it a bit simpler, I think. Differentiate dx dt is sin t differentiates to cos t, so b cos t minus 2 cos 2t. Just finish this off. I'll just go up here to do it. Dx dt is 1. T is 0, so b minus 2, so b is 3, which means my particular solution, well, a is 0, 3 sine t minus sine 2t. So not a lot of extra stuff to do there. The point made in the book, going back to this one, is because they've given me that particular integral, that's the particular integral that I'd use. Generally, if I see a trig function on the right hand side, I'd have a cos term in there as well, but I'm not going to use that because I was given the particular integral to use. So that's worth bearing in mind. And that's your lot. So have a go at 7D. Let me know if you need anything. Bye-bye.